So hi everyone, my name is Junyi Li, and today I'm going to present my research on stroke prediction system using machine learning models. So stroke is a life-threatening medical condition that can have severe consequences, which often resulting in disability and or death. And due to the high stakes, early detection is crucial for initiating immediate treatment and improving patient outcomes. And several health conditions and lifestyle factors are associated with an increased risk of stroke, including high blood pressure, heart diseases, diabetes, and so on. So by developing a reliable and accurate stroke prediction system, we can better identify individual at risk and provide preventative care. So our primary goal is to solve this question is that how can we build a model to predict stroke given features of a patient's history? And we want to develop a comprehensive stroke prediction system using various health conditions and patient attributes. We have employed the standard process to handle the data and build machine learning models, and finally deploy the most proper model and predict based on users' input. So firstly, I have imported some data set from the famous Kaggle website and through Panda, which is a software library written for the Python programming language for data manipulation and some analysis. And through using the reCSV function, we can load a CSV files as a pandas data frame. And using the info function, we can show we can see from the right side about some attribute information. For example, the age, the gender, the work type, or the BMI values. And the head function is used to access the first rows of a data frames. And we found that there is no duplicated data in this data set, so it doesn't matter. But we have to handle the missing data before further processing. And I found that there are 201 missing values in the BMI values. And in order to fix that, I fill them in with the mean value of BMI indexed. And we can move on after fixing that. Then we have to handle the categorized data. So I utilize the label encoding techniques, which is a popular techniques for handling categorized variables. So in this technique, each label is assigned with a unique integer based on the alphabetical ordering. And from the EDA, it revealed that the age, hypertension, heart diseases might be relevant to the stroke, because from the left side we can see that in the correlation matrix, the deeper the color is, the higher relation the two variables will have. And in the feature importance function, we found that age is the most significant factor that determine the risk of the stroke. And the following two are smoking status and work type. So before really importing and utilizing the machine learning models, we have to splitting the data for training and testing. So the X set contains all attributes, including age, BMI, and so on, except whether you have stroke or not. and the Y set only contains the result. So I split like 70% for training and the rest of the data set for testing. And before using using the machine learning models, we have to do one thing last is to handling the imbalanced data set, because I found that this data set is somehow imbalanced. We have to implement the smart techniques to perform oversampling. So after utilizing that smart techniques from the from the library, we fixed the problem, and then we move to the model selection part. So we train and evaluate the performance of the following machine learning models, including logistic regression, Taylor classifier, naive Bayes classifier, and so on. And we compare and evaluate them through cross-validation, and our evaluation matrix including accuracy, precision, recall, F1 score, and ROC curve. So after training each of the model, we got this result table. And since random forest and decision tree have significantly better performance on accuracy than others, so I decided to tuning the hyperparameter for these two models and see which one turns out to be the best one for the prediction system. So I import the research CV from the sklearn library, and it is a exhaustive search over some specific parameter values for and classifier, and then it determine the optimal values for a given model. So somehow the accuracy of the decision tree classifier does not being improved that much, and the accuracy of the random forest classifier has just been slightly improved. But overall, the random forest classifier still maintain the highest performance. So I will pick it as the final model to predict stroke. And in conclusion, we successfully developed a stroke prediction system using the random forest classifier, and the final accuracy rate is impressive, which is 94%, and this system has the potential to aid in the early detection of stroke risks, ultimately saving lives and improving healthcare outcomes. And future works could including integrating deep learning models such as convolutional neural networks or recurrence neural networks to further enhance the model performance and reliability. So thank you for your attention, and I will be pleased to address any questions or concerns you may have regarding to the prediction system.